Welcome to Spring LIB.
Now for this question, we're looking at a pendulum, and it's oscillating with in a simple harmonic motion. It has length of 2.23 meters, and we're given that its mass 6.74 kilograms, and the speed at its equilibrium position. I'm going to assume it is at this particular point. The velocity is 2.06 meters per second. We're going to find a few different properties of this pendulum. So the first one would be the period. Period is given as 2 pi square root L over G. Should be quite easy to find since we are given the L, which is 2.23 meters. And we should get this to be about 3 seconds, 3.00 seconds. To find the total energy, right, we just have to consider at the lowest point, which is at the equilibrium point, all the energy is converted into kinetic energy, which is just half mv square. We can find this quite simply by putting in the velocity at the equilibrium position and the mass that is given. So half mv square should get about 14.3 joules. Now for the last part, it's slightly trickier. We want to find the angular displacement, right? The maximum angular displacement. Now this is the point when all the kinetic energy is converted into gravitational potential energy, right? So in order to find this angle, what we will need to do is to first find what is the height that it has increased by from our gravitational potential energy, and from this we can actually find what is the length of this side of the right angled triangle which I have just drawn, right? We can find this length, and from this length we can find the angle theta since we know the length of the pendulum. So first this height, then this length over here, which is just L minus H, and then finally the angle. So to find the height, equate mgh to the maximum kinetic energy, which is half mv square. H will just be half v square divided by g, which is 0.217 meters. So the length over here is just 2.23 minus 0.217, and using cosine theta as our trigonometry expression, so cosine theta must be equals to adjacent over the hypotenuse, which is h over L. So from here we can find our theta by just taking cosine inverse of this, and we should be able to find the maximum angular displacement to be 25.5 degrees.